Exercise 1.1. Find the adjoint of the following. A square matrix A is given as -3, 4, 6, 2. So it has 2 rows and 2 columns. So in order to find the adjoint, we'll be finding out the cofactor matrix. For this, we'll follow a sign convention. Plus, minus, minus, plus. So in order to find the cofactor of -3, we'll be eliminating this column and this row and combine the remaining element with this sign. So cofactor matrix becomes +2 and the cofactor of 4. After eliminating that row and that column, we'll have 6. So therefore, combining with minus, it becomes -6. Similarly, the cofactor of 6 is -4 and the cofactor of 2 is -3. In order to find the adjoint A, we'll be transposing cofactor matrix. So, adjoint A is equal to +2 -6 -4 -3 transpose. Transpose is nothing but converting rows into columns. So this row will get converted into the first column and the second row gets converted into second column. Therefore, adjoint A will become 2 -6 -4 -3, which is the final answer. Therefore, this is the adjoint of the following first matrix. So moving on to the next problem, we have to find the adjoint of a 3 into 3 matrix. In order to find the adjoint of this, we need to find the cofactor matrix first. So in order to find the cofactor matrix for a 3 into 3 matrix, we'll be following a sign convention which is as follows. Plus, minus, plus, minus, plus, minus, plus, minus and plus. So this is the sign convention for 3 into 3 matrix and we'll be following this for finding out the cofactor matrix. So in order to find the cofactor of 2, we'll be eliminating this column and this row and evaluate the following square matrix. So considering this as a square matrix, you'll be multiplying this diagonal minus of the multiplication of this diagonal and consider this sign because we are going to find the cofactor of the first element. So plus, so inside the bracket we'll be multiplying this and minus of the multiplication of this diagonal. 4 into 2 will become 8 minus of 7 into 1 becomes -7. To find the cofactor of 3, you will be eliminating this row and this column and evaluate the remaining square matrix, which is nothing but 3, 1, 3, 2. So minus of, in bracket, we'll be multiplying this diagonal minus of multiplication of this diagonal. 3 into 2 is 6. 3 into 1 is 3 minus 3. Next, we'll be taking out this sign plus for finding out the cofactor of 1. So in this case, we'll be eliminating this row and this column. So you will have a square matrix which is this. Multiplying this diagonal, it becomes 3 into 7 is 21 minus 3 4s are 12. Next, we'll be finding out the cofactor of 3 and consider minus as the sign. So eliminating this row and this column, you'll have 3, 1, 7, 2. 3 into 2 is 6 and 7 into 1 is 7. So it becomes 6 minus 7. Now finding out the cofactor of 4, you will consider plus as the sign. Plus of eliminating this row and this column, you will have 2, 1, 3, 2. So multiplying the diagonal, 2 into 2 is 4, minus 3 into 1 is 3. So next, for the cofactor of 1, the sign will be minus. This row and this column gets cancelled out, and you will have 2, 3, 3, 7. 2 into 7 is 14. 3 into 3 is 9. Coming into the next row, you will have finding out the cofactors of the remaining terms. So on evaluating, we will be getting the answer as 1, minus 3, 9, 1, 1, minus 5, minus 1, 1, minus 1. So this is the cofactor matrix of A. Now we will be finding out the adjoint A. So adj A is nothing but the transpose of the cofactor matrix. So transpose is nothing but first row will become first column, second row will become second column, third row will become third column. Transposing first row to column. 1, minus 3 and 9. Second row to second column. 1, 1, minus 5. Third row to third column. Minus 1, 1, minus 1. So this is the adjoint A of matrix 2, 3, 1, 3, 4, 1, 3, 7, 2. So this is the final answer. And moving on to the third sum. Considering this sum, it is not like the previous sum. It has a constant outside the matrix. So in this case, we will be following a special kind of theorem, which is nothing but adj lambda into A, which is equal to lambda n minus 1 at j. So here lambda is equal to the constant, which is 1 by 3. So we will be substituting 1 by 3 in the place of lambda, and this n is nothing but number of rows and columns, which is nothing but 3, and therefore 3 minus 1 becomes 2 adj A. Now we will be finding out the adj A by finding out the cofactor matrix as a first step. Cofactor matrix of the 3 into 3 matrix becomes, by following the sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. So for finding out the cofactor of the first element, so you will be cancelling out this row and this column and evaluate the remaining elements. So considering the sign plus, we will have these elements to evaluate. 1 into 2 becomes 2, minus 2 into 2 becomes minus 4, but we have minus over here already, and therefore it becomes plus 4. Minus, we are going to find the cofactor of this element, and therefore cancelling out this row and this column, these are the remaining elements. So minus 2, 2, 1, 2 are the remaining elements. Multiplication of minus 2 and 2 becomes minus 4. Minus of 1 into 2, minus 2, and then the plus sign. And for this, you will be cancelling out this row and this column. You will have the remaining terms as this. Minus 2 into minus 2 becomes 4. Minus 1 into 1 is 1. So in the same way, we will be finding out the cofactors of the second row and the third row. After evaluating these elements, you'll be getting out this answer. 6, 6, 3, minus 6, 3, 6, 3, minus 6 and 6. So this is the cofactor matrix of the following A matrix. So after finding the cofactor matrix, we'll be transposing that to find out the adjoint A. So transposing is nothing but converting rows into column. So the first row becomes first column, which is nothing but 6, 6, 3, minus 6, 3, 6, 3, minus 6 and 6. So in order to find the final answer, we need to consider all these factors. So we had this in the formula. 1 by 3 square becomes, we are separating 1 by 3 into two terms. 1 by 3 into 1 by 3. And Adj is nothing but this matrix. So the reason why we are separating these terms is that each and every element from this matrix can be divided by 3. Now multiplying 1 by 3 with each and every element of the square matrix. This with this, this. So each and every term is multiplied with 1 by 3. 6 into 1 by 3 becomes 6 by 3. Minus 6 into 1 by 3 becomes minus 6 by 3. 3 into 1 by 3 becomes 3 by 3. 6 into 1 by 3 becomes 6 by 3. 3 into 1 by 3 becomes 3 by 3. Minus 6 into 1 by 3 becomes minus 6 by 3. 3 into 1 by 3 becomes 3 by 3. 6 into 1 by 3 becomes 6 by 3. 6 into 1 by 3 becomes 6 by 3. On the whole, the answer becomes 1 by 3 into the evaluation of the following elements. 6 by 3 becomes 2, minus 2, 1, 6 by 3 is 2 again, 1, minus 2, 1 again, 2 and 2 again. So this is the final answer of finding the adjoint A. So consider this, students. When you have a constant outside the matrix, you need to follow the special theorem which I have told you already. Now we will be moving on to the second sum of exercise 1.1. Find the inverse of the following. So the first sum is a 2 into 2 matrix. So in order to find the inverse, we have a specific formula. A inverse is equal to 1 by A determinant into Adj. First we will have to find out A determinant and find out adjoint A and then multiply them. So in order to find the A determinant, we know the rule that we will be multiplying this diagonal and minus it with the multiplication of this diagonal. Minus 2 into minus 3 becomes 6. 1 into 4 becomes minus 4. So which is equal to 2, which means A determinant is not equal to 0. Therefore, A inverse exists. Now we have found out the A determinant. The next step for finding the inverse is finding out adjoint A. In order to find adjoint A, we will be finding out the cofactor matrix. So for this, we know that we will be following a sign convention, which is plus, minus, minus, plus. So in order to find the cofactor matrix of -2, we will be eliminating this column and this row. So the remaining element will be -3. Combining with the symbol, it becomes -3. Similarly, cofactor of 4 is -1 and cofactor of 1 is -4. Cofactor of -3 is -2. Finding the adjoint is the next step. So for this, we'll be transposing cofactor matrix, which is nothing but converting first row into first column and second row into second column. Adjoint A is equal to, this row gets converted into first column and this second row gets converted into the second column. So the adjoint A becomes -3, -4, -1, -2. Now substituting adjoint A and A determinant in this formula, we'll be finding out A inverse. One by A determinant is 2 into adjoint A is -3, -4, -1, -2. So this is the final answer. So the next sum, we have 3 into 3 matrix. We have a formula for finding out the A inverse. 1 by A determinant into adjoint A. So first we'll be finding out A determinant. For this, we'll be following the sign convention for the first row as plus, minus and plus. Now for finding the determinant A for 3 into 3 matrix, for the first element we'll be taking +5 and cancelling out this column and this row and taking out the remaining matrix, which is 5, 1, 1, 5. Similarly, for the second element, -1, cancelling out this column and this row, we'll have 1, 1, 1, 5 inside. For the third element, we have +1, 1, 5, 1, 1 inside. When we are evaluating, this will become 25, -1, -1, 5 -1, +1, 1 minus 5. So this will become 24 minus 1. This will become 4 plus 1. This will become -4. 5 into 24 becomes 120 minus 4 minus 4, which we can take it as 120 minus 8, which is equal to 112, which is not equal to 0. Therefore, A inverse exists. So now that we have found out A determinant, the next step is finding out cofactor matrix. So for this, we'll be using a sign convention: plus, minus, plus, minus, plus, minus, plus, minus and plus. In order to find the cofactor of 5, we'll be eliminating this row and this column and evaluate the remaining terms. Multiplication of leading diagonal, which is 25 minus 1 minus 5 minus 1 plus 1 minus 5 minus 5 minus 1 plus 25 minus 1 minus 5 minus 1 plus 1 minus 5 minus 5 minus 1 plus 25 minus 1. So after evaluation, we get 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4 and 24. So by transposing cofactor matrix, we will be getting the adjoint A. Adjoint A becomes 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4, 24. As we know, transposing is nothing but converting rows into columns. Now, by substituting the value of A determinant and adjoint A, we will be finding out A inverse. So A inverse will be equal to 1 by 112 into adjoint A, which is 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4 and 24. So if we have a look at this matrix, we come to a conclusion that 4 is common in all the elements present in this matrix. So taking 4 outside the matrix, we'll have 4 by 112. So taking 4 from 24, so the remaining element will be 6. Similarly, this will get converted into minus 1 and the same minus 1, minus 1, 6, minus 1, minus 1, minus 1, 6 again. So when we cancel out 4 and 112, we'll be getting 1 by 28. Which is the final answer. Moving on to the third subdivision. So we have a formula for A inverse. A inverse is equal to 1 by A determinant into adjoint A. So first we'll find out A determinant. So in order to find A determinant, we'll be following the sign convention only for the first row, which is plus, minus, plus. So for the first element, plus 2, cancelling out this column and this row, we'll have 4 into 2, which is 8, minus 7 into 1, which is 7. And for the second element, minus 3, the remaining elements will be 3 into 2, 6, minus 3 into 1, which is 3. And the next element, plus 1. Cancelling out this row and this column, we'll have 3 into 7, which is 21, and 3 into 4, 12. So 21 minus 12. After evaluation, this will become 1 minus 3, and this will become 3 plus 1, and 21 minus 12 becomes 9. 2 into 1 is 2, minus 3 into 3 is 9, and plus 9. So which is equal to 2. Therefore, this is not equal to 0. Therefore, A inverse exists. So the next step is finding cofactor matrix. We know the procedure, so I'm directly writing the answers. After implying the sign convention, which is plus, minus, plus, minus, plus, minus, plus, minus, plus. So after multiplying the diagonals and minusing with the other diagonal, plus 1 minus 3 9 plus 1 1 minus 5 minus 1 1 minus 1. So the next step is finding out the adjoint A. So for this we will be transposing cofactor matrix. So after transposing we will be getting 1 minus 3 9 1 1 minus 5 minus 1 1 minus 1. So A inverse. So in order to find A inverse, we will be substituting the values of A determinant and adjoint A. So A determinant is 2, therefore 1 by 2 into adjoint A, which is 1 1 minus 1 minus 3 1 1 9 minus 5 minus 1, which is the final answer.